Hello everyone, welcome back to my channel Code with me. This is Gurkirat Singh in front of you, and we are going to start with a new topic, that is a to-do link list. So before that to-do link list, like it is a sub part of linked list, let us learn about what is a linked list. So linked list is a kind of a data structures which help us to arrange the data structures, like arrange the data and any kind of data we have to arrange. It can be done with the linked list. So in a to-do linked list, we are going to do perform the task management things. We are assigning some task, we are removing some task, we can view a task, but that is done with the help of linked list. Like we can arrange them in a linear way. So let's begin our journey. So firstly, like as it is a part of a linked list, I just want to tell you about what actually the linked list is. So see, for the linked list thing, suppose this is the we can consider it or refer it as an example of the train. Okay, so like in a train there is one engine, that is the kind of we can say a head thing and all. So I am considering this as a head. Okay, this is a head. So this is going to be joined with the like this is the head thing. Okay, this is the main thing of the linked list from where we are getting to the start of the linked list. So this specific thing we can say as a node. Like this thing itself is called node. So what exactly the node is? So node is something where we can store the data and we can refer the another node to that node, like we can give a reference. So how this node actually works, I'll tell you. Suppose this is the one node. Okay, its one part is divided, uh, let's see, yeah. So yeah, here we can store our data. Whatever the data we are having, we can store. Let me type only. So here we can do the data thing. We can store the data, and for the this side here we can give a reference to the another node if any another node exists. If exists, here we can store the, yeah, here we can store its reference, like what are the memory, like when we are going to store something, so the memory, in the RAM where it is stored, we give that reference to this. So when we give the reference of the another node, suppose we are having this another node, yeah, just give me a second, yeah, so we are having this another node. Okay, so it is also containing some data. Here suppose any data, just for us imagination I can think, here it is 5, and here I can say, like suppose here it is 11. Okay, so this 5 is stored in the memory at some data, at some like number or something like that we can store in a memory. We can say it is stored in 100 in the RAM. Okay, now this 100 act as a reference which we combine or which we stored here. When we put this 100 into here, this or this linked list combined together. Now we can say this first node is having a link with the second node, and this first node itself is called a head. Like for the every node or for the every linked list, the first one is called as a head. So if any one not exists, the one which we create the first, that is a head, or if there is existence of the linked list, the first one we can refer as a head, and the remaining one only the node itself. Okay, yeah, that can be node itself. So this is a little bit example of the linked list. So we are going to do the to-do linked list. So in to-do, instead of this node and these things, we are going to assign some tasks, like we can assign task, we can complete task, we can view task, we can delete task with the help of linked list. Only thing is happening, like instead of these numbers, I'll give you example, just give me a second. Yeah, instead of these numbers, suppose this is a first one block. second block, third block, okay. And what we will do, will combine together all these blocks in which we assign some task. Like firstly, for example, here any task we give, like suppose any task we can do, like let's see, washing, suppose, okay. Then here we can say cleaning. Like I am taking example of car, so washing car, cleaning car, then drying it, or like something like that. So we are assigning some task in a linear way. Okay, so same thing happened with the to-do list. We are assigning some tasks in a series. So this is the visual representation of the to-do link list. And if we want to assign one more task, let's suppose I want to assign one more task, just simply, firstly I have to create one node, that is a one task. Then we have to link it with the last task so that there is a linking between everything. Okay, so like this is the assignment. And when we want to remove, we just have to remove it. It's simple. And there is something for a view, so we can view this tasks by by writing the code. We can view all the tasks, like what are the tasks in the series and all. So now let's start with our coding part. Yeah. So let's begin. I will explain the code with itself right now. So for that, I am using the Python language. So like I am considering you are little bit know about the language and all. So I am just starting. Okay. Like I explain the major terms, but I'm considering that you all know little bit. So this is the class, like whatever the classes we learn in the Python, that class in which we are having some like objects and classes in which we can sometimes use inheritance and all. So yeah, so that class we are using, and we are assigning a class task node. Instead of node, we are just assigning node. Here we are using the constructor thing, and this in constructor one is a self, that is help to like we can reach at the points where we want. Like when we ask, like I want this, I write object from there, it can go to that particular task, and it can do its working. So task is what we are giving it. Okay, so it's like that, self dot task is equals to task, and self dot next is equals to none. So why it's none? Because right now we don't know is there any another task exists or not. If it exists, then okay, but if it doesn't exist, then it's none. So in a starting, we can do like this. After that, now this is just for making a node, one assigning one task, one box. Now we are going to make the linked list. Like linked list is the combination of all the nodes. So from here we can make one node. Now we are going to make the linked list class. We are going to make the to do linked list. To do linked list. Okay. So in to do linked list, def same here constructor we are using with same self. Okay, here we only use self because here we just want to come into the to-do link list. Here we don't want any task and all. That will become, but later. We assign self dot head is equals to 9. Like we just assign one variable in which we are asking that is a none. Okay, that is a none right now. So now next thing is like def another function which I am making. uh, Give me a second. So another function which I am going to make, that is the add task. So here I am going to the add task. So firstly, let tell me one thing. When we are going to add some task, we want task like we want some task. Like I want to add something, so I want material. So here I am giving self, that is just to reach that particular point, and task itself. Like whatever the task I want, I give the task here. After that, assigning a new task. So now we give the task. Now we have to store it somewhere. So new task is equals to task node task. What I did here, I assign a new variable new task in which I store this thing. I call this thing into here. So whenever I run this add task, it will go back to here. It will check whatever the value I have given. It will take the value, insert here and assign to the new task. So in this way it's working. Okay. Next thing we have to check if self.head is none. Like suppose we are creating a new list, okay, linked list. So at that time self.head is obviously none. It doesn't exist. If self.head is none, then what we have to do, then we have to self dot assign self dot head is equals to new task. Whatever the task we are getting, the first we have to assign it to the self dot head. But suppose if it already exists, then what we have to do, we have to create a we can say like a temporary variable in which we can say this is the self dot head. Okay, temporary variable in which cell dot help, while temp dot next, while means after just give me a second. Like see, until this temporary, the next of the temporary is none, we are going to add. But suppose if the temporary dot next is not none, then we have to assign this temporary with some value like temp dot next. So if the temporary dot next is not none, we have to shift that temporary to the next temporary. What I can say, what I mean to say, suppose in a row five children are standing, three are having chocolates. I go to the first student, he is having chocolate. What I do? I will shift from first student to second student. Okay, same thing happened here. If the temp dot next is not none, uh, if the temp dot next is not none, then assign temp is equals to temp dot next. After it reaches to temp dot next, what we will do, when it reaches, like this is a loop until it doesn't reach at that point where it gets to be none, it will continuously moving. After a certain point, when it reach to that particular point, then we can say that now temp dot next is equals to we assign that value new task. I think this is understandable. Okay, so in this way we can add a task. Okay, now let's come to our next method, that is the remove. Now if I want to remove any task, def remove task. Okay, so first of all, while removing the task, we have to do self comma whatever the task we want to remove. Okay, we have to mention like see, like I can mention I want to remove this task. Okay, so if self dot head, if self dot head wait. If self dot head is none. Suppose linked list not exist, even not exist. If self dot head is none, we can simply print no task to remove. Okay, we can simply say no task to remove because if linked list is not exist, if head is not there, it means there's no linked list. So it's clear cut like linked list is not there, so we can't remove any task. Next, here we return. Okay, then if the task to remove is the head, if we want to remove the task which is the head, the engine we want to remove. Suppose if we want to remove the engine. Okay, so like it's not exactly like we can't say like this. We can't proceed with that example. It's just an example. But if we remove to head, so if self dot head dot task double equals to task. Suppose whatever the task we want to remove, if they both matches, then we can say one thing self dot head. Now we consider that self dot head is equals to self dot head dot next. What I did here, wait,
So what I did here, I just do one thing. Like if the self dot head dot task is equals to the task which we mentioned, self dot head is one thing, dot task, like whatever the task first is there, and whatever the task we mentioned, if both are matches, then the self dot head, what whatever the self dot head is.
one. Suppose for there are five students, one, two, three, four, five. One is having a chocolate, but two is not having. Now I want to give, I don't want to give to the first, I want to give it to the second. I want to remove the first student. What I will do, when I am going to remove the first student, I will took his chocolate and give to the second student. That is the same thing happened here. Okay, this is the second scenario. Okay, now, now we have to search for the task also, like in case if in linked list if we mention some task but if it is not there, so what should we do? Here I can do one thing. I temporary variable I create where I write self dot head, like start from the self dot head, while temp dot next, while temp dot next and temp dot next dot task not equals to the task which we mentioned. Uh, then we can say temp is equals to temp dot next. What I am doing here, firstly I create one variable temporary that is a self dot head. I say if the that like here it is clear that head is there, but like if we consider like if the next of the temporary, if the second student and the next of the and if the second and the second student is not having the chocolate which we want to give, then we have to shift it to the third student. Simply whatever the next is, whatever the next of the head, if it is not equal to the task which we give, then just move to the third person or the third node. Okay, so when we are going to the third node, it just shift to the third node. Now next is, now if, now we move to the next node. Now if that temp dot next is none, is not none, if that temp not next is not none, like exists something, then we can say temp dot next equals to temp dot next dot next, like we are shifting twice.
print no task found. So it's very simple. If the temp not x is not none, if that is also not none, so we can shift twice two more tasks, and if that is also
there is no task found. Like it's shifting, 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 and all. After a one point, when the linked list is going to finish, so in this line, we can say this is that line where our linked list gets finished. That's why we write next dot next. So it means we can't find. So else we write print no task found. Now let's start. It's running. For that, we have to firstly make the objects. So to-do list we can consider is we have to use the same class's name. So in this, I made object. First, I am going to add. So to do list dot add task. Okay. So I am going to add a task. Suppose by groceries. Next, let me just copy this. Next, next. I am adding three tasks. Okay. Cleaning the house, finishing homework. Before that, I just forget one thing. Like this is the task which we made, but how we can display all these things? So we have to display these things also. For that, we also have to make one function that is the display function, display task. So here we are going to write self, comma. Here we only need the self so that we can reach to this point. After reaching here self, just give me a second. If self dot head is none, print no task in the list. Okay, else. So see, if the self dot head is none, it means it doesn't exist. Linked list doesn't exist. So we can say no task in the list. Else, if exists, firstly we make a temporary variable in which we stored self dot head. Okay. So while temp, so we are going to print each temp, like whatever the value we are having in the temp. So temp dot task. After printing one by one, we are shifting to the temp is equals to temp dot next. So it works only where temporary is having some hold or having some values. When it gets to the finish, it's not working. So it's a way of displaying the task. Now let's come back to the our original like finishing part. So finish homework is there, add task. Now I'm printing here. This is to-do list. To-do means task list. Okay, so this is a to-do list. Yeah. Now for displaying, this is just we mentioning this is our to-do list. Now mentioning that to-do list, we have to write all to-do underscore list, the same object with the functional name display task. Okay, with the display task. So yeah, here we done. After that, now we have to remove the list also. For removing, right, for removing, clean the house. Like firstly, I have to give whatever I want to remove. So same object to do list dot remove task. Okay. So I am mentioning here. Suppose I want to remove the finish homework. I write finish. I have to see the spelling also because if we write wrong, it will be not work. Finishing homework. Okay, this is done. Now we can see the updated portion like print.
Updated to do list. So here we go again.
So this is our whole code. Now let's see its output and yeah, it's ready. It's 5. Okay, so it's saying there is one mistake. So we can see, okay, yeah, one mistake is there. I didn't close it. So this is our to-do list by groceries. See, this is our to-do list by groceries, cleaning the house, finishing the homework. After that, the updated list when I delete finishing the homework, it's only the buy groceries and the cleaning house. For the more understandable thing, we can do one thing. Just give me a second. Before removing, just I'm commenting this all. Now I'm going to run. When I'm running this, I get this is to-do list. Whatever the in the list, buy groceries, cleaning the house, and finishing the homework. Okay, so this is the our to-do list which we exist. Now I want to remove that. Okay, so now what I did, I use this remove task in which I am mentioning I want to remove the finishing one. So this is the updated list and this we have to use for the show. So see, initially buy groceries, cleaning the house, finishing the homework. But after that updated to-do list, we are having the buy groceries and the cleaning house. Finishing the homework is removed now. So in this way, we can use a linked list and this is the way we use the to-do list. And it's a kind of specialized list as it help us to managing the task and all. And that's all from my side. Thank you so much. If